At 12 volt also it is 220 volt. Now you can see input current and output current. The inverter is working from the capacitor on the PCB. Medi launches the new transformerless online UPS up to 6 kVA. At Medi, we develop the technology from scratch. The hardware circuit is first designed, followed by software developed to suit the specific requirements of the hardware design. Prototypes are then assembled. Rigorous testing under all conditions are carried out before launching the product in the market. This is Medi's double conversion online UPS up to 6 kVA. Transformerless multi-level switching topology with active power factor correction and current harmonic reduction with static bypass. This is a compact design with very few components, easy to assemble and extremely low cost. This is the AC input, AC output, neutral common and battery input. This design will support both MOSFETs and IGBTs. We have very low cost isolated gate drive for both MOSFET and IGBT. Now we are showing a wide range of battery voltage. Input from 12 volt to 300 volt, output will be constant 220 volt AC. Switch on the inverter. See, the output is 220 volt. Oscilloscope connected to the output. Now showing from 63 volt variable power supply instead of battery. Let us reduce the input voltage. At 18 volt also it is 220 volt. At 12 volt also it is 220 volt. Now the input is 10 volts and then only the output voltage came down. Now we are showing from 300 volt variable power supply instead of battery. Let's cover the lamp from reflection. Let us reduce the input voltage. See, the output is 220 volt. Now let us show no load test. We are going to remove the power supply and instead of battery, the inverter is working from the capacitor on the PCB and the output still remains. As you can see, it is taking very low current, which means it is high efficiency. Now let us conduct short circuit test from the battery. Mains not connected, battery connected. Switch on the inverter. See the AC output waveform. Let us short circuit. As you can see, nothing happens. Again, let's short circuit more than 4 to 5 seconds. Then it goes to cut off. Now inverter is shut down. We can restart it. Let us conduct rough short circuit test from battery with the load. As you can see, nothing happens. Again, switch on. Again, let us do rough short circuit. Short circuit test from mains with load. Again, let's short circuit more than 4 to 5 seconds. Then it goes to cut off. Short circuit test from battery and mains. Inverter on. Now mains is switched on. You can see the oscilloscope. You can see the meter. Now let us connect inductive load directly through mains. You can see the input current and voltage, output current and voltage. AC in is given to AC out. You can see the current, both are the same. You can see the AC input and AC output voltage waveform, both are the same. Now the inductive load is connected through MLS online UPS. AC input is given through ammeter to the UPS. Neutral is connected both here and here also. This is AC output connected through the ammeter and we have connected inductive load and bulb. See the AC input current and AC output current. Battery is not connected. Switch on the inverter. Now you can see input current and output current. The input current is only 1.65 ampere and output current is 8.28 ampere. And see the AC output voltage and input voltage. We are now testing with non-linear load. You can see this has very high current harmonics and 20 ampere peak to peak. Now let us switch the current clamp meter to the input. You can see the current came down. It's only 6.1 ampere. The power factor has improved and current harmonics has come down. The power factor has improved to 0.95, while the harmonics has reduced to 3%. SiC MOSFETs used up to 6 kVA and IGBTs used up to 5 kVA. For 6 kVA, Medi has designed a customized silicon carbide device. These MOSFETs can be used specifically for 6 kVA application.